Thank you very much for that warm welcome. I would like to thank the organizing committee and all of the volunteers in the 4th International Conference on Machine Intelligence and Signal Processing organized by National Institute of Technology, Raipur, India. My name is YOUNES-AZIZ PhD student. My doctoral advisor is Hisham Monsef, Laboratory of Innovation in Mathematics, Application and Information Technologies, Sultan Moulay Slimane University, Morocco. I will present the paper entitled The Study of Effectiveness of Automated Essay Scoring in MOOCs. It's an opportune time to renew contact and discuss problem. The plan will be as follows: background, literature survey, problem description, methodology, result and discussion, and finally a conclusion. Today, e-learning has emerged as a key issue with application in every business, including supported training, lifetime learning modes, and support tools for all types of educational institutions. As a result of the COVID-19's impact, millions of applicants take online tests via MOOC platforms. And while scoring brief response is crucial to the process, it becomes difficult to grade them using human graders. Unfortunately, multiple choice quizzes are inadequate for measuring higher level learning that extend beyond the lower level Bloom's taxonomy. As a result, developing and implementing a generic automated system for grading this response is crucial. Utilizing computers to evaluate and grade students' assignments, simplify and cut costs, we investigate an automated answer scoring technique that combines machine learning technique with automatic natural language processing to produce a fast, scalable, and accurate result. We divided major EAS approaches into three categories: regression model, classification models, and neural network models. The regression models failed to find cohesion and coherence from the essay because it's trained on bag of words feature. In processing data from input to output, the regression models are less complicated than neural network. Susan 2020 proposed a text mining approach for short answer grading. First, they're comparing model answer with student response by calculating the distance between two sentences. By comparing the model answer with student response, they find the essay's completeness and provide feedback. Salim 2019 proposed an XGBoost machine learning classifier to assess the essay. The algorithm trained on features like word count, pause, part of tree depth, and coherence in the article with sentence similarity percentage. Cohesion and coherence are considered for training, and they implemented k-fold cross-validation for a result. The average accuracy after specific validation is 68.12. Evaluation can take numerous shapes and forms, which may vary depending on the learning objectives and disciplinary setting, and the technology that is available to participants. Peer assessment is frequently distinguished using a formative or summative approach. There are various components that must be included when putting together an essay assignment. A set of questions or prompts for students to respond to, a set of guidelines. The assessments use a single rubric to grade all the questions. There are various types of assessments. Review both assessments can be used in conjunction with other types of assessment, such as peer and staff evaluation and self-assessment as seen in the figure. There are 8 essay sets in this computation dataset. Each pair of essays was generated in response to a specific prompt. Selected writing range in length from 150 to 550 words on average. Some of the essays rely on secondary sources while others do not. All essays were written by children in grade 7 through 10. All essays were graded by hand and scored twice. Each of the 8 data sets is distinct and its own way. The unpredictability is designed to push the capabilities of scoring engines to their limits. Table 1 summarizes the data essays were hand-scored on a variety of scales, depending on the prompt, with each essay receiving at least 2 scores. To train and evaluate the learning model for this research, essay set 1 to 3 were utilized. The model can recognize and scale the scale difference and generate the appropriate grade. The data had already been pre-processed by using the Stanford Natural Language Processing Group. Feature extraction. 11 open source libraries were used to build a total of 16 features. Heuristic characteristics. Numerous heuristic elements were produced that are likely to add to the quality of an essay. Several heuristic aspects include the following: word count, big word count, word with a length greater than 6, average word length per essay, quotation mark count, character count, sentence count, and comma count. Grammatical and spelling feature. It is expected that a learner will make grammatical and spelling error. Grammar check created a large number of spelling and grammatical problems. Tag for part of speech (POS) account for most common POS tags. Was utilized to assess and determining a decent sentence structure. For example, a count of noun, verb, adjectives, and adverb for a specific essay using NLTK. Additional characteristic. Additionally, crucial metrics such as incorrect word, domain word, the quantity of words that are relevant to the essay domain, punctuation, count, and word-to-sentence ratio were generated using LTK WordNet library. Single feature kappa. Following the generation of the heuristic feature, each one was examined independently to determine its contribution to the learning model. We used the method to avoid overfitting. It employed linear regression as the learning model and a 5-fold cross-validation technique with quadratic weighted kappa as the evaluation metric. Greedy forward selection. According to the single kappa score obtained, the features were ordered and decreased in order. We used the forward selection approach to select the feature set with the greatest kappa score. Optimization, word-to-vec model since its inception in 2013, the word-to-vec model has demonstrated interesting application in the natural language processing field. To improve the model accuracy, used the Jensen library word-to-vec model and combined the resulting word vector with the previously built heuristic feature vector. Any improvement in accuracy was welcomed, as relying exclusively profitable for NLP tasks. The produced sentence list was used to construct the word-to-vec model with 300 features. A 300-dimension word vector were created for training and testing purposes. These vectors were then concatenated with the previously created heuristic feature vector. The majority of the AES systems are using the evaluation metric. They are quadratic weighted kappa, mean absolute error, Pearson correlation coefficients. The quadratic weighted kappa will find agreement between a human evaluation score and system evaluation score and produce value ranging from 0 to 1. We ran the model via skill-learned dummy regressor to determine whether the learned model outperformed a model that always guesses one answer. It received a kappa score of 0, suggesting that there was no agreement between the projected values and the grade assigned by a human grader. Linear regression using the concatenated vector of word-to-vec model and heuristic feature, a linear regression model with 5-fold cross-validation was then trained after evaluating the model with the test vector. An average kappa score of 0.93 was obtained during cross-validation. The final model, which was constructed using the word-to-vec model, generated word vectors, and the heuristic feature performed remarkably well. The score increased by 0.26 points when compared to employing purely heuristic feature, which was the method taken by a large number of competitors during the competition. The final score of 0.93 outperformed the benchmark by a factor of 0.543, and the model outperformed the winning team's score, showing the utility of utilizing a word-to-vec model for NLP tasks. We were specifically looking for response to the following question. To begin, to what extent may machine learning be used to enhance current method of peer review grading? Second, will the model produced perform well in terms of accuracy? For this portion of the project, only essay sets 1, 2, and 3 were used. Adding the next 5 essay sets to the model should have no effect on its efficiency, as the essay in these 5 sets contain essays comparable to those in essay set 3, which were created by a single prompt. The heuristic qualities were developed by considering the broad characteristics of an effective essay. These characteristics should be applicable to any essay in any domain. Similarly, a huge corpus was used to train the word-to-vec model. This should verify that the model is applicable to any essay input domain on which it was trained. The deep learning approach is very popular at present. The deep learning algorithm provided a great result for this task. Thank you.